Hello there, and welcome to BioTales Science. I'm so glad you found your way here tonight. Maybe you've had a long day, or perhaps you're simply the kind of person who finds comfort in drifting off to gentle thoughts about the mysteries within us rather than counting sheep. Either way, this journey is for you. You have nothing to do right now but rest. Let your shoulders drop, your breathing slow, and your thoughts settle like dust after a breeze. Because tonight, we aren't just learning about science. We're wandering through the soft corridors of the human brain, the most intricate structure in the known universe, folded quietly inside your skull. 3 pounds of tissue holding 100 billion neurons, each one connecting to thousands of others in patterns more vast than the stars in the Milky Way. But beneath its complexity lie secrets, gentle truths about memory, emotion, dreams, and the quiet hum of consciousness itself. We'll drift from the brain's ancient core to its wrinkled outer surface, from the chemistry of sleep to the mystery of why we forget, from the neurons that fire when you smile to the hidden rhythms that keep you alive without thought. Some of what you hear tonight may surprise you, or at the very least, offer a soft curiosity as you slip towards sleep. And just before we begin, if these calm explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to BioTales Science. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. Your brain never truly rests. Even now, as you lie still, as your muscles relax and your breathing deepens, your brain continues its quiet work. It consumes about 20% of your body's energy, though it makes up only 2% of your weight. While you sleep, it consolidates memories, clears out waste, and rehearses the patterns of the day. It is always listening, always organizing, always humming beneath the surface of your awareness. The brain doesn't know how to be idle. It simply shifts its focus from the outer world to the inner one, weaving dreams from fragments, sorting emotions like papers on a desk, and preparing you for tomorrow without asking permission. Your brain is mostly fat and water. For all its mystery, the brain is built from humble materials. Nearly 60% of it is fat, lipids that form the insulating sheaths around neurons and make up the structure of cell membranes. The rest is water, protein, and trace minerals. It is soft, delicate, with the consistency of firm jelly. It would collapse under its own weight if not suspended in cerebrospinal fluid, floating gently inside the skull like a thought inside silence. This fragile organ, mostly fat and water, holds everything you are: your memories, your personality, your ability to love and wonder and dream. It is strange to think that something so soft could be so powerful. The brain has no pain receptors. The brain itself cannot feel pain. You can touch it, press it, even cut it, and it will not hurt. Surgeons sometimes operate on conscious patients, mapping the brain's surface while the person remains awake, speaking, moving, thinking. The skull and the membranes around the brain have pain receptors, which is why headaches hurt, but the brain tissue itself is silent to its own touch. In a way, the organ that allows you to feel everything feels nothing of itself. It is the conductor of sensation, not the recipient. It listens to the body, interprets every signal, but remains untouched by its own existence. Every thought is an electrical storm. When you think, when you remember, when you feel, your brain lights up with electrical activity. Neurons fire in synchronized bursts, sending signals across synapses at speeds up to 268 miles per hour. Each thought is a cascade, a pattern of activation rippling through networks built over years of experience. Some patterns are well-worn, like familiar paths through a forest. Others are new, forming as you learn, as you adapt, as you grow. These electrical storms are constant, overlapping, creating a symphony of activity that never fully quiets. Even in sleep, the brain flickers with light, dreaming in waves of electricity too faint to feel but profound enough to shape who you are. Your brain rewires itself every day. The brain is not fixed. It changes continuously, sculpting itself in response to experience. This is called neuroplasticity, the ability of the brain to form new connections, strengthen old ones, and prune away what is no longer needed. Every time you learn something new, practice a skill, or remember a moment, your brain physically changes. Synapses grow stronger, new pathways form, old ones fade. This process continues throughout your life, though it slows with age. The brain you have today is not the brain you had yesterday, and it will not be the brain you have tomorrow. It is always becoming, always reshaping itself in the quiet spaces between thoughts. The brain is divided, but works as one. The brain has two hemispheres, left and right, separated by a deep fissure but connected by a thick bundle of fibers called the corpus callosum. For many years, people believed the left brain was logical and the right brain creative, but the truth is more nuanced. Both sides work together on nearly every task, communicating constantly, sharing information across millions of neural bridges. The left hemisphere tends to focus on details, language, and sequences, while the right processes patterns, spatial relationships, and emotional tone. But these are tendencies, not absolutes. The brain is not split into opposing forces. It is a collaboration, a partnership, two halves dancing together in intricate harmony. You use all of your brain, not just 10%. This myth has persisted for decades, but it is simply not true. Brain imaging studies show that even during simple tasks, nearly all regions of the brain show some level of activity. Different areas activate depending on what you're doing, thinking, or feeling, but over the course of a day, you use virtually every part of your brain. Evolution would not waste energy building and maintaining tissue that serves no purpose. The brain is efficient, and every region has a role, from the ancient structures that keep you breathing to the newest layers that let you imagine the future. You are using your whole brain right now, even as you drift toward sleep. The brain creates your sense of time. Time is not something you perceive directly, like light or sound. It is constructed by your brain, stitched together from memory, attention, and the rhythm of neural firing. When you're engaged and focused, time seems to fly. When you're bored or waiting, it drags. This is because your brain encodes more memories during novel or emotionally charged experiences, making those moments feel longer in retrospect. Time is not a river flowing at constant speed. It is a story your brain tells itself, flexible and shifting, shaped by what you notice and what you ignore. Even now, as you settle into stillness, time softens, stretches, and begins to lose its edges. Your brain can hold about 7 items in working memory. Working memory is the mental workspace where you hold information temporarily, like a phone number you're about to dial or the steps of a recipe you're following. Research suggests that most people can hold around 7 items at once, give or take 2. This limit is why you chunk information, grouping digits into patterns or words into phrases. Your brain is constantly managing this small stage, deciding what to keep in focus and what to let fade. It is a narrow spotlight in a vast theater, and most of what you experience never makes it into long-term storage. It simply passes through, briefly illuminated, then gone. Sleep clears waste from your brain. While you sleep, your brain does something remarkable. It activates a waste clearance system called the glymphatic system, which flushes out toxic proteins and metabolic byproducts that accumulate during waking hours. Cerebrospinal fluid flows through the brain's tissues, washing away debris like a gentle tide. This process is most active during deep sleep, which is one reason why chronic sleep deprivation is so harmful. Without enough rest, waste builds up, impairing cognition and increasing the risk of neurodegenerative diseases. Sleep is not idleness. it is maintenance, a nightly rinse that keeps your brain clean, clear, and ready for tomorrow. The brain consumes a quarter of your glucose. Though small, the brain is a hungry organ. It uses about 25% of the glucose in your bloodstream, fuel for the constant firing of neurons and the maintenance of synaptic connections. This is why thinking hard can make you feel tired, and why low blood sugar affects your mood and focus. The brain prioritizes its own needs, drawing energy even when the rest of the body is conserved. It is the most metabolically demanding tissue you have, burning through calories even when you're sitting still, even when you're asleep. Every thought, every memory, every flicker of awareness costs energy, and the brain pays that price without pause. Your brain predicts the future constantly. You don't experience the world as it is. You experience the world as your brain predicts it will be, based on past experience. This predictive processing happens so quickly that you're usually unaware of it. Your brain generates expectations about what you'll see, hear, and feel, and then updates those predictions based on incoming sensory data. This is why optical illusions work, and why you can finish someone's sentence before they do. Your brain is not a passive receiver. It is an active interpreter, constantly guessing, adjusting, and filling in gaps to create a coherent sense of reality. Even your perception of now is slightly delayed, a best guess assembled from signals that take time to process. Memories are reconstructed, not replayed. When you remember something, you are not accessing a perfect recording. You are rebuilding the memory from fragments, piecing it together from scattered neural patterns. Each time you recall a memory, you reconstruct it slightly differently, influenced by your current emotions, beliefs, and context. This is why eyewitness testimony can be unreliable, and why childhood memories often feel more like stories than snapshots. Memory is creative, not archival. It is shaped by repetition, emotion, and meaning, and it changes every time you revisit it. The past is not fixed in your brain. It is fluid, rewritten softly with every act of remembering. Your brain has a default mode. When you're not focused on a specific task, when your mind wanders or daydreams, a network of brain regions becomes active. This is called the default mode network, and it's involved in self-referential thinking, memory consolidation, and imagining future scenarios. Far from being idle, this network is deeply engaged, processing your sense of self, your relationships, and your place in the world. Mind wandering is not a failure of attention. It is a different kind of thinking, one that allows for creativity, reflection, and emotional integration. Your brain, even when it seems to be doing nothing, is quietly weaving the threads of your inner life. Neurons communicate through chemical messengers. The brain's electrical signals don't jump directly from one neuron to another. Instead, they cross tiny gaps called synapses using chemical messengers called neurotransmitters. When an electrical impulse reaches the end of a neuron, it triggers the release of these chemicals, which float across the synapse and bind to receptors on the next neuron, continuing the signal. This chemical conversation happens billions of times per second throughout your brain. Different neurotransmitters have different effects. Dopamine influences motivation and reward. Serotonin affects mood and sleep. GABA calms neural activity. Each one plays a role in the delicate balance that keeps your brain functioning smoothly. The brain is shaped by what you pay attention to. Attention is not just about focus. It is about shaping the structure of your brain. When you repeatedly pay attention to something, whether it's music, math, or meditation, the neural networks involved in that activity grow stronger and more efficient. This is how practice works at the biological level. Musicians develop enhanced auditory processing regions. Taxi drivers in London, who must memorize complex routes, show enlarged hippocampi. What you choose to focus on literally sculpts your brain over time. Attention is not passive. It is the chisel that carves the shape of who you become. Your brain fills in blind spots without you knowing. There is a small region in each of your eyes where the optic nerve connects to the retina, and this spot has no photoreceptors. You are literally blind there. But you never notice this gap, because your brain fills it in seamlessly, using information from the surrounding area and from your other eye. It invents what should be there based on context and expectation. This happens constantly, in real time, without any conscious effort. Your brain is not showing you the world as it truly is. It is showing you a version of the world that makes sense, patched together from fragments, predictions, and educated guesses. Sleep moves through distinct stages. When you sleep, you don't simply shut down. Your brain cycles through different stages, each with its own unique pattern of activity. Light sleep eases you in, slowing your heart rate and relaxing your muscles. Deep sleep follows, where your brain waves become long and slow, and your body repairs itself. Then comes REM sleep, where your eyes dart beneath closed lids and your brain becomes almost as active as when you're awake. This is when most vivid dreams occur. These stages repeat in roughly 90-minute cycles throughout the night, each one serving a different purpose, each one essential to rest and restoration. The hippocampus is essential for forming new memories. Deep within the brain, curved like a seahorse, lies the hippocampus. It plays a crucial role in converting short-term memories into long-term ones. Without it, you can still recall old memories, but you cannot form new ones. This was famously demonstrated in a patient known as HM, who had his hippocampus removed to treat severe epilepsy. Afterward, he could remember his childhood but could not retain new experiences for more than a few moments. Every conversation was new, every face unfamiliar. The hippocampus is the brain's librarian, deciding what to keep and what to discard, shaping the story of your life one memory at a time. Emotions are processed in the limbic system. Beneath the outer layers of the brain lies a collection of structures known as the limbic system, the emotional heart of the mind. The amygdala detects threats and triggers fear. The hippocampus links emotions to memories. The hypothalamus regulates stress hormones. Together, these regions create the feelings that color your experience, from joy to sorrow, from anger to love. Emotions are not separate from thought. They are woven into every decision, every memory, every perception. The limbic system ensures that what matters to you emotionally is what your brain remembers and prioritizes. The prefrontal cortex makes you human. At the very front of your brain, just behind your forehead, sits the prefrontal cortex. This region is involved in planning, decision-making, impulse control, and social behavior. It is what allows you to think about the future, weigh consequences, and choose actions based on long-term goals rather than immediate desires. It develops slowly, not fully maturing until your mid-20s. This is why teenagers often take risks and struggle with self-control. The prefrontal cortex is the conductor of your personality, the part of the brain that makes you thoughtful, reflective, and uniquely yourself. Your brain is more active during REM sleep than when awake. REM sleep, the stage associated with vivid dreaming, is paradoxical. Your body is paralyzed to prevent you from acting out your dreams, but your brain is wildly active, consuming almost as much energy as it does during waking hours. Blood flow increases. Neurons fire in rapid, complex patterns. This is when your brain processes emotions, consolidates procedural memories, and makes creative connections between disparate ideas. Some researchers believe REM sleep is when the brain rehearses scenarios, solves problems, and integrates experiences. It is not rest in the traditional sense. It is a different kind of waking, turned inward. Mirror neurons help you understand others. In the early 90s, researchers discovered a remarkable type of neuron that fires both when you perform an action and when you watch someone else perform the same action. These are called mirror neurons, and they may be the biological basis for empathy, imitation, and social learning. When you see someone smile, Mirror neurons in your brain activate as if you were smiling too. When you watch someone in pain, your brain simulates that pain. This mirroring allows you to understand others not just intellectually, but experientially. You feel what they feel, in a quiet, neural echo. The brain can generate its own opioids. When you experience pleasure, exercise intensely, or even laugh deeply, your brain releases endorphins, natural chemicals that resemble opiates like morphine. These endorphins bind to the same receptors in the brain that pain medications target, producing feelings of euphoria and reducing the perception of pain. This is the source of the runner's high and the warm glow after a good meal or a hug. Your brain has its own pharmacy, capable of producing substances that heal, comfort, and reward you from within. It is a system designed to encourage behaviors that promote survival and connection. Language lives primarily in the left hemisphere. For most people, language processing is concentrated in the left side of the brain, particularly in two key regions. Broca's area, located in the frontal lobe, is involved in speech production and forming sentences. Wernicke's area, in the temporal lobe, is responsible for understanding language. Damage to Broca's area results in difficulty speaking, though comprehension remains intact. Damage to Wernicke's area produces fluent but nonsensical speech, with impaired understanding. These areas work together in a network that allows you to translate thoughts into words and words into meaning, a uniquely human ability shaped by millennia of evolution. The cerebellum coordinates movement with precision. Tucked beneath the back of the brain, the cerebellum looks like a smaller, wrinkled version of the whole organ. Though it makes up only 10% of the brain's volume, it contains more than half of its neurons. The cerebellum is responsible for coordinating movement, balance, and posture. It fine-tunes your motor commands, ensuring that when you reach for a glass of water, your hand moves smoothly and stops at exactly the right moment. It also plays a role in learning motor skills, from riding a bike to playing an instrument. Without the cerebellum, movement would be clumsy and uncoordinated, like trying to walk on a ship in rough seas. Your brain creates reality from incomplete information. The world you perceive is not a direct representation of reality. It is a construction, built by your brain from fragmentary sensory data. Your eyes send signals, your ears capture vibrations, your skin detects pressure, but none of these inputs are complete or perfectly accurate. Your brain takes these pieces and assembles them into a coherent experience, filling in gaps, smoothing out inconsistencies, and making assumptions based on past experience. This constructed reality is so seamless that you never question it, but it is always an interpretation, a best guess, shaped as much by your brain's expectations as by the world outside. Stress shrinks the hippocampus over time. Chronic stress is not just emotionally draining, it physically changes your brain. Prolonged exposure to stress hormones like cortisol can damage neurons in the hippocampus, causing it to shrink. This is why people who experience long-term stress often struggle with memory and learning. The hippocampus is vulnerable, sensitive to the chemical environment of the brain, but the damage is not always permanent. Reducing stress, practicing mindfulness, and getting adequate sleep can help the hippocampus recover and even grow new neurons. The brain is resilient, capable of healing when given the right conditions. The brain's wrinkles increase its surface area. The outer layer of the brain, the cerebral cortex, is deeply folded into ridges and grooves. These wrinkles, called gyri and sulci, dramatically increase the surface area of the cortex without requiring a larger skull. If you could unfold the cortex and lay it flat, it would cover about 2.5 square feet, roughly the size of a large pizza. This expanded surface allows for more neurons and more complex processing. The wrinkles are not random. They follow patterns shaped by genetics and development, creating the unique topography of each individual brain. Dopamine drives motivation, not just pleasure. Dopamine is often called the pleasure chemical, but that's only part of the story. Dopamine is more accurately described as the motivation chemical. It surges not when you experience pleasure, but in anticipation of reward. It drives you to seek, to pursue, to take action. This is why dopamine is involved in addiction, learning, and goal-directed behavior. It creates the wanting, the craving, the sense that something good is just within reach. Without dopamine, you would lack the drive to do much of anything. With too much, you might chase rewards compulsively, never satisfied. The brain uses about 20 watts of power. All the complexity of thought, emotion, memory, and consciousness runs on roughly the same amount of energy as a dim light bulb. 20 watts. That's all the brain needs to process sensory information, regulate your body, store memories, and generate the rich inner world of your experience. It is astonishingly efficient, far more so than any computer. This efficiency comes from the parallel processing of billions of neurons working simultaneously, each one performing simple operations that together create extraordinary complexity. The brain is proof that power is not just about energy. It is about organization, connection, and design. Forgetting is a feature, not a bug. We often think of forgetting as a failure, but it is actually an essential function. Your brain is constantly deciding what to keep and what to discard, filtering out irrelevant details to make room for what matters. If you remembered everything, your mind would be cluttered with trivial information, making it harder to think clearly and make decisions. Forgetting allows you to generalize, to extract meaning from experience, and to adapt to new situations. It is a form of mental housekeeping, clearing away the noise so the signal can come through. The brain forgets on purpose, and that purpose is efficiency. Your sense of self is constructed by the brain. The feeling of being you, the sense of continuity and identity that persists through time, is not a given. It is actively constructed by your brain, moment by moment. Regions like the medial prefrontal cortex and the posterior cingulate cortex integrate memories, sensory information, and social context to create a coherent sense of self. This is why damage to certain brain areas can alter personality or disrupt the sense of identity. The self is not a fixed entity. It is a process, a story the brain tells itself, woven from neurons and shaped by experience. The brain can rewire itself after injury. When part of the brain is damaged by stroke, trauma, or disease, other regions can sometimes compensate, taking over lost functions. This remarkable ability is called neuroplasticity, and it is strongest in children but persists throughout life. After a stroke, patients can regain speech or movement through intensive therapy that encourages the brain to form new pathways. The brain is not hardwired. It is adaptive, resourceful, and capable of reorganizing itself in response to challenge. Recovery is possible, though it requires time, effort, and the right support. The amygdala processes fear and threat. Deep within the temporal lobes, almond-shaped structures called the amygdala scan your environment for danger. They react to threats before you're consciously aware of them, triggering the fight or flight response in milliseconds. Your heart races, your muscles tense, your attention narrows. This ancient system kept our ancestors alive, alerting them to predators and hazards. Today, it still activates in response to real threats, but also to perceived ones, like public speaking or social rejection. The amygdala doesn't distinguish between physical danger and emotional stress. It simply sounds the alarm, preparing your body to respond. Dreams may help process emotions. During REM sleep, when most dreaming occurs, the brain is highly active in emotional centers like the amygdala and hippocampus, but less active in the prefrontal cortex, the region responsible for logical thinking. This unique state may allow the brain to process and integrate emotional experiences without the constraints of rational analysis. Dreams often feel strange and illogical because they're not meant to make sense. They're meant to help you work through feelings, rehearse responses, and file away experiences. The content of dreams is less important than the emotional processing happening beneath them, quietly sorting through the day's residue. Your brain weighs about 3 pounds. For all its power and complexity, the adult human brain weighs roughly 3 pounds, about 1.4 kilograms. It's small enough to hold in 2 hands, yet it contains approximately 86 billion neurons, each connected to thousands of others. These connections form networks that span the entire brain, creating pathways for thought, memory, and sensation. The brain's weight hasn't changed much over thousands of years, but its internal organization has become increasingly sophisticated. Evolution didn't make the brain bigger. It made it more efficient, more connected, more capable of abstract thought and complex behavior. Oxytocin is the bonding hormone. When you hug someone you love, hold a baby, or share an intimate moment, your brain releases oxytocin. This hormone strengthens social bonds, increases trust, and promotes feelings of warmth and connection. It's released during childbirth and breastfeeding, helping mothers bond with their infants. It's also involved in romantic attachment and friendship. Oxytocin doesn't just make you feel good, it changes how you perceive others, making you more empathetic and more likely to cooperate. It is the chemical foundation of love and belonging, woven into the fabric of human connection. The brainstem controls automatic functions. At the base of your brain, where it meets the spinal cord, lies the brainstem. This ancient structure controls the most basic functions necessary for survival: breathing, heart rate, blood pressure, digestion, and sleep-wake cycles. These processes happen automatically, without conscious thought, regulated by the brainstem's rhythmic signals. Even in deep sleep or unconsciousness, the brainstem keeps you alive, maintaining the delicate balance of systems that sustain life. It is the foundation upon which all higher brain functions rest, the quiet guardian that never sleeps. You have about 86 billion neurons. That's the best current estimate of the number of neurons in the human brain. Each neuron can connect to thousands of others through synapses, creating trillions of possible connections. These networks are what allow for thought, memory, learning, and consciousness. Neurons are not static. They form new connections throughout life, especially when you learn something new or practice a skill. They also die off naturally as you age, but the brain compensates by strengthening remaining connections. The number is staggering, but it's the organization and communication between neurons that truly matters, not just the count. The thalamus is the brain's relay station. Almost all sensory information entering your brain, sight, sound, touch, taste, passes through the thalamus first. This central structure acts as a relay station, sorting and directing signals to the appropriate regions of the cortex for processing. It filters out irrelevant information and amplifies what's important, helping you focus on what matters in your environment. Without the thalamus, your senses would be chaotic, overwhelming, impossible to interpret. It is the gatekeeper of perception, quietly organizing the flood of data that pours into your brain every moment. Sleep deprivation impairs judgment, like alcohol. Going without sleep for 24 hours affects your brain similarly to having a blood alcohol level of 0.1% above the legal limit for driving in most places. Your reaction times slow, your attention wanders, and your ability to make sound decisions deteriorates. Chronic sleep deprivation compounds these effects, leading to memory problems, emotional instability, and increased risk of accidents. The brain needs sleep not just to rest, but to function. Without it, cognitive performance crumbles, sometimes without you even realizing how impaired you've become. The brain can change its own chemistry through practices like meditation, exercise, and positive thinking. You can influence the chemical balance in your brain. Meditation increases serotonin and GABA, promoting calm and reducing anxiety. Exercise boosts endorphins and dopamine, improving mood and motivation. Even gratitude practices can shift neural patterns, strengthening pathways associated with positive emotions. The brain is not a fixed machine responding only to external inputs. It is dynamic, capable of self-regulation and transformation. What you do, how you think, and how you live all shape the chemical environment of your mind. The brain generates about 70,000 thoughts per day. That's the estimate, though the exact number is difficult to measure. Some thoughts are conscious and deliberate, like planning your day or solving a problem. Others are fleeting, automatic, barely noticed. Many thoughts are repetitive, cycling through familiar worries, memories, or daydreams. The brain is never quiet. It churns constantly, generating ideas, images, and inner dialogue. This endless stream of thought is what creates your inner world, the narrative that runs beneath everything you do. Learning to observe these thoughts without being controlled by them is one of the skills of mindfulness, a way to find stillness within the storm. Neurogenesis happens in the adult brain. For many years, scientists believed that you were born with all the neurons you would ever have, and that no new ones could form after early childhood. But research has shown that neurogenesis, the birth of new neurons, does occur in certain regions of the adult brain, particularly the hippocampus. These new neurons play a role in learning, memory, and mood regulation. Exercise, mental stimulation, and adequate sleep all promote neurogenesis, while chronic stress and poor lifestyle choices inhibit it. The brain is not fixed. It can grow, adapt, and renew itself throughout life. The insular cortex processes self-awareness. Tucked deep within the folds of the brain lies the insula, a region involved in interoception, the sense of what's happening inside your body. It monitors your heartbeat, breathing, hunger, pain, and emotions, integrating these signals into your conscious awareness. The insula is also involved in empathy, allowing you to feel what others are feeling by simulating their internal states. It is the bridge between body and mind, the part of the brain that creates the felt sense of being alive, of being present in your own skin. Your brain consumes oxygen constantly. The brain uses about 20% of the oxygen you breathe, far more than its size would suggest. Neurons need oxygen to produce the energy required for their constant firing and communication. If blood flow to the brain is interrupted, even for a few minutes, neurons begin to die. This is what happens during a stroke. The brain's hunger for oxygen is relentless, and it prioritizes its own needs above almost everything else. Every breath you take, a fifth of it goes to fueling the thoughts, memories, and sensations that make up your experience. Habits are stored in the basal ganglia. When you first learn a new behavior, it requires conscious effort and attention, engaging the prefrontal cortex. But as you repeat the behavior, it gradually moves into the basal ganglia, a set of structures deep in the brain involved in habit formation. Once stored there, the behavior becomes automatic, requiring little conscious thought. This is why habits are so hard to break. They're encoded deeply, running on autopilot. But neuroplasticity means habits can be changed. It takes time, repetition, and conscious effort to rewire these pathways. But it is possible. The brain interprets pain. It doesn't create it. Pain is not just a signal from an injured body part. It is a complex interpretation created by the brain, influenced by context, expectation, and emotion. This is why the same injury can feel more or less painful depending on your mental state. Soldiers in battle sometimes don't notice severe wounds until later. People given placebos can experience real pain relief. The brain is constantly evaluating whether pain is necessary, whether it will help you avoid further harm. Pain is real, but it is also subjective, shaped by the brain's predictions and priorities. The occipital lobe processes vision. At the very back of your brain sits the occipital lobe, dedicated almost entirely to processing visual information. Signals from your eyes travel to this region, where they're decoded into edges, colors, shapes, and motion. Different areas within the occipital lobe specialize in different aspects of vision. Some neurons respond only to horizontal lines, others to vertical. Some detect movement, others color. These specialized cells work together to construct the rich visual world you experience. Vision feels immediate and effortless, but it's the result of extraordinary processing happening in the darkness at the back of your skull. Meditation can physically change the brain. Regular meditation practice has been shown to increase gray matter in regions associated with attention, emotional regulation, and self-awareness. It can thicken the prefrontal cortex and strengthen connections between brain areas involved in focus and calm. Meditation also reduces activity in the amygdala, the brain's fear center, leading to lower stress and anxiety. These changes are not just psychological, they are structural, visible on brain scans. Meditation is not just relaxation, it is training, a way of deliberately shaping your brain toward greater balance and resilience. The anterior cingulate cortex detects conflict. When you face a difficult decision or encounter conflicting information, the anterior cingulate cortex activates. This region monitors for errors, conflicts, and unexpected outcomes, signaling when something doesn't match your expectations. It's involved in cognitive control, helping you adjust your behavior when things don't go as planned. It also plays a role in emotional regulation and pain perception. The anterior cingulate is like an internal alarm system, alerting you when attention is needed, when something requires deeper thought or a change in strategy. Your brain creates a model of your body. You have an internal map of your body in your brain, a representation of where your limbs are, how they're positioned, and how they move through space. This is called proprioception, and it's updated constantly by sensory feedback. The brain uses this map to coordinate movement, maintain balance, and interact with the environment. Sometimes this map can be distorted, as in phantom limb syndrome, where someone feels sensation in a limb that's been amputated. The brain's model persists even when the body changes, showing how deeply rooted these representations are. The brain's energy comes entirely from glucose. Unlike muscles, which can use fat for fuel, the brain relies almost exclusively on glucose for energy. It cannot store glucose, so it depends on a constant supply from the bloodstream. This is why blood sugar levels have such a direct impact on mental function. When glucose drops too low, you feel foggy, irritable, and unable to concentrate. The brain is demanding and particular about its fuel, and it prioritizes its own needs even when the rest of the body is in conservation mode. Every decision, every memory, every moment of awareness is powered by sugar, quietly burning in the background. The parietal lobe integrates sensory information. Located near the top and back of the brain, the parietal lobe processes touch, spatial awareness, and the integration of sensory data. It helps you understand where your body is in space, how objects relate to one another, and how to navigate your environment. Damage to the parietal lobe can result in strange symptoms, like neglecting one side of your body or being unable to recognize objects by touch. This region is essential for creating a coherent sense of the physical world, blending sight, touch, and movement into a unified experience. Your brain fills in missing sounds in speech. When you listen to someone speak, especially in noisy environments, your brain often fills in missing or unclear words based on context and expectation. This is called phonemic restoration. You don't hear every sound perfectly, but your brain predicts what should be there and inserts it seamlessly. This is why you can understand speech, even when words are mumbled or interrupted. Your brain is not passively receiving language. It is actively constructing meaning, using prior knowledge and pattern recognition to complete the puzzle. The vagus nerve connects brain and body. The vagus nerve is the longest nerve in your body. running from your brainstem down through your chest and abdomen, connecting to your heart, lungs, and digestive system. It carries signals in both directions, allowing your brain to regulate organ function and allowing your organs to send information back to the brain. This is why deep breathing can calm your mind, why gut feelings influence decisions, and why your heart rate changes with emotion. The brain and body are not separate. They are in constant conversation, mediated by pathways like the vagus nerve. Childhood experiences shape brain architecture. The brain is most plastic during early childhood, when neural connections are forming rapidly based on experience. Positive experiences, like nurturing relationships, play, and learning, help build strong, healthy neural networks. Adverse experiences, like trauma, neglect, or chronic stress, can disrupt development and alter brain structure. These early patterns create a foundation that influences emotional regulation, learning ability, and stress response throughout life. But the brain remains capable of change. With support, therapy, and new experiences, it can form healthier patterns, even after difficult beginnings. The temporal lobe processes sound and language. On the sides of your brain, just above your ears, lie the temporal lobes. They are responsible for processing auditory information, understanding language, and forming long-term memories. Wernicke's area, located here, allows you to comprehend speech. Damage to the temporal lobes can result in difficulty understanding language, recognizing faces, or forming new memories. This region also plays a role in emotional processing and the sense of personal identity. It is where sound becomes meaning, where words become thoughts, and where experience becomes memory. Sleep cycles repeat every 90 minutes. Throughout the night, your brain moves through cycles of light, sleep, deep sleep, and REM sleep, each lasting roughly 90 minutes. As the night progresses, deep sleep becomes shorter and REM periods become longer. This is why you often wake from a dream in the early morning. Each cycle serves a purpose. Deep sleep restores the body and consolidates factual memories. REM sleep processes emotions and integrates learning. Interrupting these cycles, even if you get enough total sleep time, can leave you feeling unrefreshed. The brain needs to complete its nightly rhythm to function well. The frontal lobe governs executive function. The frontal lobe, particularly the prefrontal cortex, is responsible for what neuroscientists call executive functions: planning, organizing, problem-solving, impulse control, and working memory. It allows you to think about the future, consider consequences, and make decisions that align with your goals. This region matures slowly, which is why children and teenagers struggle more with self-control and long-term thinking. The frontal lobe is what makes deliberate action possible, what lets you override instinct and emotion in favor of reason and intention. The brain can experience neurological illusions. Just as optical illusions trick your visual system, neurological illusions can distort your perception of reality. Phantom limb sensations make you feel a missing body part. Synesthesia blends senses, so you might see sounds or taste colors. Déjà vu creates the eerie feeling that you've experienced a moment before. These phenomena reveal the constructed nature of perception. Your brain is always interpreting, predicting, and sometimes making mistakes. What you experience as solid reality is actually a fragile simulation, held together by neural patterns that can occasionally glitch. Laughter activates multiple brain regions. When you laugh, it's not just a simple response. Multiple brain areas light up, including regions involved in motor control, emotion, language processing, and reward. Laughter is social and contagious, triggering mirror neurons that make you want to join in. It releases endorphins, reduces stress hormones, and strengthens social bonds. Genuine laughter is one of the most complex behaviors your brain produces, engaging cognitive, emotional, and physical systems simultaneously. It is a form of communication older than language, a universal signal of joy, connection, and safety. The brain filters most sensory input. Every second, your senses are bombarded with millions of pieces of information: sights, sounds, smells, textures, temperatures. But you're consciously aware of only a tiny fraction. Your brain filters out the vast majority, deciding what's relevant and what can be ignored. This filtering happens automatically, guided by attention, expectation, and survival needs. You don't notice the feeling of your clothes against your skin until someone mentions it. You don't hear the hum of the refrigerator until it stops. The brain protects you from sensory overload by creating a simplified, manageable version of reality. Acetylcholine supports learning and memory. This neurotransmitter plays a crucial role in attention, learning, and memory formation. It is released when you focus on something new or important, helping to encode that information into long-term storage. Acetylcholine also facilitates communication between neurons, strengthening synaptic connections. In diseases like Alzheimer's, acetylcholine levels drop significantly, leading to memory loss and cognitive decline. This is why some treatments for dementia aim to boost acetylcholine activity. The brain needs this chemical messenger to learn, to remember, and to stay sharp as you age. The cerebral cortex is only a few millimeters thick. The outer layer of your brain, the cerebral cortex, is remarkably thin, only about 2 to 4 millimeters. Yet this thin sheet of tissue contains the majority of your neurons and is responsible for most of what we consider higher thought, reasoning, language, consciousness, and voluntary movement. Its thinness is what allows it to be folded so extensively, maximizing surface area without requiring an impossibly large skull. Evolution found an elegant solution, packing immense processing power into a compact, wrinkled surface. Emotions influence memory formation. Not all memories are created equal. Emotionally charged events are remembered more vividly and for longer than neutral ones. This is because the amygdala, which processes emotion, interacts closely with the hippocampus during memory formation. When something makes you feel strongly, whether joy, fear, or sadness, your brain tags it as important and encodes it more deeply. This is why you remember where you were during significant life events but forget what you had for lunch last Tuesday. Emotion is the brain's way of marking what matters. The brain uses half its neurons for vision. Despite having multiple senses, your brain dedicates enormous resources to processing visual information. Roughly half of the cortex is involved in vision in some way, either directly analyzing images or using visual information for other tasks. Vision is complex, requiring the detection of edges, colors, motion, depth, and patterns, all integrated into a coherent scene. This heavy investment reflects how crucial sight has been for human survival. We are visual creatures, and our brains reflect that priority in their architecture. The suprachiasmatic nucleus controls your internal clock. Deep in the hypothalamus lies a tiny cluster of cells called the suprachiasmatic nucleus, the master clock of your body. It regulates your circadian rhythms, the roughly 24-hour cycles that govern when you feel awake and when you feel sleepy. This clock is synchronized by light, which is why exposure to sunlight helps you stay in rhythm and why artificial light at night can disrupt your sleep. The suprachiasmatic nucleus sends signals throughout the brain and body, coordinating everything from hormone release to body temperature to match the time of day. The brain is approximately 73% water. Water is essential for every function of the brain. It cushions the tissue, transports nutrients, removes waste, and facilitates the electrical signaling between neurons. Even mild dehydration can impair cognitive function, affecting memory, attention, and mood. The brain's high water content also makes it vulnerable to changes in hydration status. This is why staying hydrated is not just about physical health. It directly impacts how well you think, how clearly you remember, and how stable your emotions remain. The cingulate cortex links emotion and cognition. Wrapped around the corpus callosum, the cingulate cortex serves as a bridge between emotional and cognitive processing. It's involved in regulating emotion, predicting rewards, making decisions, and focusing attention. It helps you evaluate whether something is worth pursuing, whether a situation is safe, and how you should respond. The cingulate cortex is part of what makes you a feeling, thinking being, integrating what you know with how you feel to guide your actions. Practice literally changes neural pathways. When you practice a skill, whether it's playing piano, speaking a language, or solving math problems, you're not just getting better at the task, you're physically changing your brain. Repeated activation of neural pathways strengthens the connections between neurons, making the signals faster and more efficient. Myelin, a fatty substance, wraps around frequently used pathways, insulating them and speeding up transmission. This is the biological basis of skill acquisition. Practice doesn't just improve performance, it rewrites the brain. Your brain can process images in milliseconds. The speed at which your brain processes visual information is astonishing. Research suggests that you can recognize the essence of a scene, whether it's a beach, a city, or a forest, in as little as 13 milliseconds. This rapid processing happens unconsciously, before you're even aware of what you're seeing. Your brain is constantly scanning, categorizing, and interpreting visual input at speeds far beyond conscious thought. By the time you're aware of seeing something, your brain has already done most of the work. The brain can adapt to sensory loss. When one sense is lost, the brain often compensates by enhancing others. People who are blind from an early age often develop heightened hearing and touch, and brain imaging shows that their visual cortex is recruited for processing these other senses. The brain doesn't let valuable neural real estate go to waste. It reorganizes, redirects, and adapts. This plasticity demonstrates that brain regions are not rigidly fixed to one function. They are flexible, capable of taking on new roles when circumstances change. The brain is resourceful, always finding ways to work with what it has. Music activates nearly the entire brain. Few activities engage as much of the brain as listening to or playing music. Music processing involves auditory regions, motor areas for rhythm and movement, emotional centers for feeling, memory systems for recognizing melodies, and language areas for lyrics. Playing an instrument adds even more complexity, requiring fine motor control, timing, and coordination. This is why music therapy can be effective for various neurological conditions. Music is a whole brain experience, weaving together cognition, emotion, and movement in ways that few other activities can match. The brain prioritizes faces over other objects. Humans are social creatures, and your brain reflects this with specialized regions for recognizing faces. The fusiform face area, located in the temporal lobe, responds more strongly to faces than to any other visual stimulus. You can recognize a face in an instant, even from unusual angles or poor lighting. This ability is so automatic that you see faces in clouds, in toast, in random patterns. Your brain is wired to find and interpret faces because social connection has been crucial to human survival. You are built to see each other. Cortisol, the stress hormone, affects memory. When you're stressed, your adrenal glands release cortisol, which affects many systems in the body, including the brain. In moderate amounts and for short periods, cortisol can actually enhance memory formation, helping you remember dangerous or important situations. But chronic stress and prolonged cortisol exposure damage the hippocampus, impairing your ability to form new memories and recall existing ones. This is why chronic stress is so harmful to cognitive function. The brain can handle short-term stress, but it suffers under long-term pressure. The brain's white matter is mostly connections. While gray matter contains the cell bodies of neurons, white matter consists primarily of axons, the long fibers that connect different brain regions. These axons are wrapped in myelin, a white fatty substance that gives white matter its color and speeds up signal transmission. White matter makes up about half the brain's volume and is essential for communication between different areas. It's the wiring that allows distant regions to work together, creating the integrated networks that underlie all complex thought and behavior. Theta waves appear during light sleep and meditation. Your brain produces different types of electrical rhythms depending on your state of consciousness. Theta waves, which oscillate at 4 to 8 cycles per second, are associated with light sleep, deep relaxation, and meditative states. They're also present during REM sleep and are thought to play a role in memory consolidation and creativity. When you're in a theta state, your conscious mind quiets and your subconscious becomes more accessible. This is the borderland between waking and sleeping, a state where insight and intuition can emerge. The brain can hold contradictory beliefs simultaneously. Human thinking is not always logical or consistent. Your brain can hold beliefs that contradict each other without necessarily recognizing the conflict. This is called cognitive dissonance, and it happens because different beliefs are stored in different neural networks that don't always communicate. You might know that smoking is harmful, but continue to smoke. You might believe in equality, but hold unconscious biases. The brain compartmentalizes, allowing you to function even when your beliefs don't perfectly align. Recognizing these contradictions is the first step toward resolving them. The olfactory bulb connects smell directly to memory. Smell is unique among the senses. It bypasses the thalamus and connects directly to the limbic system, particularly the amygdala and hippocampus. This is why sense can trigger vivid memories and strong emotions instantly. A whiff of a particular perfume might transport you back to childhood. The smell of rain might evoke a specific moment. This direct connection between smell and memory is why olfactory memories are often more emotional and more enduring than other types. Smell is the sense of memory, intimate and immediate. The brain processes negative information faster. Your brain has a negativity bias, a tendency to pay more attention to negative information than positive. Threats, criticisms, and dangers are processed more quickly and remembered more strongly than positive experiences. This bias made sense evolutionarily, when missing a threat could be fatal. But in modern life, it can lead to anxiety, pessimism, and stress. Understanding this bias doesn't eliminate it, but it can help you consciously balance your attention, deliberately noticing and savoring positive experiences to counteract the brain's natural tendency toward the negative. The brain continues developing into your 20s. While the brain grows rapidly in childhood, it doesn't finish maturing until your mid to late 20s. The prefrontal cortex, responsible for judgment, planning, and impulse control, is one of the last regions to fully develop. This is why adolescents and young adults are more prone to risk-taking and less skilled at long-term planning. The brain is still sculpting itself, pruning unnecessary connections and strengthening important ones. Development is not just about growth. It's about refinement, about becoming more efficient and more specialized over time. The brain can generate new brain cells in adulthood. For decades, scientists believed that neurogenesis stopped after childhood. But we now know that certain areas of the adult brain, particularly the hippocampus, continue producing new neurons throughout life. These new cells integrate into existing networks and contribute to learning and memory, exercise, mental stimulation, social interaction, and even certain foods can promote neurogenesis. The brain is not a fixed organ that only degenerates with age. It retains the capacity to grow, to renew, to regenerate. With the right conditions, it can remain vital and adaptive for a lifetime. Your brain generates its own cannabinoids. The brain produces chemicals called endocannabinoids, which bind to the same receptors as compounds found in cannabis. These natural cannabinoids play roles in mood regulation, pain perception, appetite, and memory. They're part of the endocannabinoid system, which helps maintain balance in various physiological processes. The runner's high, that feeling of euphoria after intense exercise, may be partly due to increased endocannabinoid production. Your brain has its own internal pharmacy, capable of producing substances that regulate mood, reduce pain, and promote well-being. The colostrum may integrate consciousness. Deep within the brain, beneath the cortex, lies a thin sheet of neurons called the colostrum. Its function has long been mysterious, but some researchers believe it may play a role in integrating information from different brain regions to create unified conscious experience. The colostrum connects to nearly every part of the cortex, making it well-positioned to coordinate activity across diverse areas. While consciousness remains one of neuroscience's greatest mysteries, structures like the colostrum offer clues about how the brain weaves separate streams of information into the seamless experience of being aware. The brain can be tricked by placebos. When you believe a treatment will help you, even if it's a sugar pill with no active ingredients, your brain can produce real physiological changes. This is the placebo effect, and it's remarkably powerful. Brain imaging shows that placebos can activate the same neural pathways as actual medications, releasing natural painkillers and altering brain chemistry. The placebo effect demonstrates that the brain doesn't just respond to reality, it responds to belief, to expectation, to meaning. Your thoughts can influence your biology in ways that are measurable and significant. Sleep spindles protect sleep from disruption. During stage 2 sleep, your brain produces brief bursts of rapid brainwave activity called sleep spindles. These spindles appear to play a role in memory consolidation, but they also seem to protect sleep from external disturbances. People who generate more sleep spindles are better able to sleep through noise and other disruptions. Their brains create a kind of shield, filtering out sensory information that might wake them. Sleep spindles are one of the ways your brain prioritizes rest, actively working to maintain the sleep you need. The brain makes decisions before you're aware of them. In studies where people are asked to make simple choices, brain activity predicts their decisions several seconds before they consciously feel they've made a choice. This suggests that much of decision-making happens unconsciously, with awareness arriving as a kind of afterthought. This doesn't mean free will is an illusion, but it does suggest that conscious experience lags behind neural processing. Your brain is working beneath awareness, processing information and preparing actions before you consciously know what you're going to do. Gratitude changes brain structure over time. Regularly practicing gratitude, consciously acknowledging things you're thankful for, can physically alter your brain. It strengthens neural pathways associated with positive emotion and weakens those tied to negativity and stress. Brain imaging studies show increased activity in areas related to reward and social bonding when people express gratitude. Over time, this practice can shift your baseline mood, making you naturally more optimistic and resilient. Gratitude is not just a feeling. It's a practice that reshapes the brain, cultivating patterns that support well-being. The brain is the most complex structure we know. With its billions of neurons, trillions of connections, and intricate networks spanning multiple scales, the human brain is the most complex object in the known universe. We've mapped distant galaxies, split the atom, and decoded DNA, yet the brain remains profoundly mysterious. How does matter become mind? How do electrical signals create the richness of subjective experience? These questions persist, humbling and inspiring. The brain is not just something you have. It is what you are, the source of everything you think, feel, and know. And now, the secrets begin to fade into softness. We've wandered together through 100 gentle truths, from the neurons that fire when you think to the chemicals that shape your mood, from the structures that hold your memories to the rhythms that guide your sleep. You've journeyed through the folds of the cortex, the ancient depths of the limbic system, and the quiet pathways that connect it all. You are not separate from your brain. You are your brain, experiencing itself, reflecting on itself, resting now in the knowledge of its own mystery. The matter inside your skull is what allows you to wonder, to love, to dream. Every neuron, every synapse, every chemical messenger is part of the story of who you are. Tonight, as you rest, your brain continues its work. It consolidates the thoughts of the day, clears away waste, and prepares you for tomorrow. Neurons fire in gentle rhythms. Memories settle into place. Dreams begin to form in the quiet spaces between waking and sleep. You are safe here, held in the arms of your own biology, cradled by systems that have evolved over millions of years to keep you alive, aware, and connected to the world. If you happen to still be awake, know that sleep will come when it's ready. There is no pressure, no urgency. You can let go whenever you wish. And if you've already drifted away, then these words are simply companions to your dreams, soft echoes fading into the night. Thank you for spending this time with Bio-Tales Science. I hope you sleep well, dream softly, and wake tomorrow with a sense of wonder for the extraordinary organ that makes it all possible. Good night.